All right, good afternoon, everyone. Before we get started on today's lesson, as usual, I have a couple things to say. I know, when do I not? First thing I want to do is remind you about assignments. So you guys do have a couple of assignments this week, nothing too crazy. There's one mathletics assignment about solving equations, and then there's also one written assignment. It's just 2 pages long. So the first page is solving different types of equations. So it starts with some easier examples, moves into some longer ones. And then second page is all word problems. So some of these word problems we're actually going to do very similar, if not identical problems together in class later this week. So don't stress too much if you can't do those yet. You definitely will be able to get them done before it's due on Friday. So things that you should be working on this week would be the mathletics assignment as well as this assignment number 3. If you missed class yesterday, no problem. Just highly recommend taking a look at the class video from yesterday. So post in the usual place under the video lessons tab. Yesterday was February 3rd. I mentioned some really important stuff at the beginning of class, just about the rest of the semester as well as the rest of this unit. Building off of that, we do have a quiz coming up next week. So the quiz is planning to be on Wednesday. I don't even know what date that is. I think it's the 12th? Yeah, Wednesday the 12th. So we still have just over a week until that. We have a couple things we need to finish up this week content-wise, and then once we're done that, next week will be review. Okay, let's just make sure that this is all in the screen here. Okay, so we started this note yesterday, solving equations with variables on both sides, but we didn't get very far into it. So I'll just sort of go over quickly the beginning of the note again. With all of these problems, all of these solving equation problems, what we're trying to do is get the variable on one side of the equation by itself. So when we have variables on both sides of the equation, what we're aiming to do is group those variables together. So if they're the same variables, if they're like terms, we can do that. And then group all of the numbers together. So numbers without variables. So one side of our equation will just be the variable. The other side will be the number that represents. So a couple of hints we want to remember. We want to look at the sign that's in front of the coefficient or variable, and also notice if there is a coefficient in front of the variable. If both sides have a negative coefficient in variable, we're going to add both sides of the equation by the term that has the bigger coefficient, because that's going to get us a positive answer. When both sides have a positive coefficient in variable, we're going to subtract both sides of the equation by the term with the smaller coefficient, because again, that's going to keep our answer positive. When we have a mix, if we have a positive coefficient in variable and a negative coefficient in variable, we're always going to move the negative term, because then we're going to move it by adding, right? Opposite of subtraction is addition, and that will get it again to be a positive number. When we're doing the above steps, remember that you need to move the whole term. So that means the coefficient and the variable. You can't leave either of them behind. So if you're trying to move a 2x from one side of the equation, you're moving the 2 and the x. They're a package deal. You can't separate them. Okay, so we did this first problem here, so we won't talk about that. We'll just jump into the next one. So this next problem here, we have x minus 9 on one side, and then negative 15 plus 7x on the right. So we have two different, they're not different. We have two variables here. They're both the same terms though, right? These will be like terms. So we have an x on the left as well as a positive 7x on the right. Okay, it's a positive 7x because I'm taking that positive sign with it. This positive sign belongs to the 7x. Okay. Now, when our rule said if we had two positive numbers or two positive terms, we're going to move the smaller term so that our number stays positive. So what I'm going to do is I have this x by itself. Now, remember, when a variable is by itself without a coefficient, it means it has a coefficient of 1. So this x actually means 1x. So right now, this x is positive. If I want to get rid of it from the side of the equation, what I'm going to do is I'm going to subtract it. So I have a positive x, I want to get rid of it, I'm going to subtract x. Have to do that to both sides of the equation, okay? So that leaves me with a negative 9 on the left, negative 15, I haven't done anything with that yet, and then I have this positive 7x, but I'm subtracting 1x from it. So 7x minus x would be 6x, and it's still a positive number, right? Because 7 minus 1 is positive 6. So my equation's gotten a little bit shorter. Now I only have a variable on one side of the equation. This is becoming a little bit easier to solve. Now what I want to do is I want to get all of my numbers together. So all those numbers that don't have variables involved. So this -9 and this -15. I'm going to add this -15 to get rid of it because then it's going to make a positive number on both sides, right? So -15, the opposite of that is adding 15. Do that to both sides of the equation. -9 plus 15 is going to give you a positive 6. Okay, and then on the right side of the equation, we just have 6x by itself. Then this just becomes a matter of getting the variable by itself. So right now my variable is being multiplied by 6. If I want to get rid of that multiplying by 6, I divide by 6 and do it to both sides of the equation. You end up with x by itself on the right, and then on the left, 6 divided by 6 is pretty easy division because it's just going to be 1. So x in this equation should be equal to 1. Now you know what I'm going to say. I'm going to say that we should check our answer because then we can be absolutely sure that we did the math correctly. So I'm going to rewrite my equation. I'm not going to change anything. I'm just going to replace all of my x's with 1s. Okay, so x becomes 1, and on this side x becomes 1 again. Okay. So what's going to happen here is I'm going to do both of these problems. So I have 1 minus 9. So it's not the nicest subtraction problem because I'm dealing with integers. 1 minus 9 is going to be -8. On the right side of the equation, I have a couple things going on. I need to do this multiplication first. So 7 times 1 is just 7. So I have -15 plus 7. Okay. -15 plus 7 is actually going to be -8. So I have both sides of my equation are balanced, right? I have the same number on both sides, which means I solve for this equation correctly, and the value of x is positive 1. Okay, let's take a look at the next example. So the next example, we have 5x plus 2 equals -3x plus 18. Again, the first thing we're going to do is we're going to get our variables together. So I have a 5x and I have a -3x. Now, when you have a positive term and a negative term, you're going to move the negative term so that you stay positive. So -3x, the opposite of that is going to be adding 3x, if I do that to both sides of my equation. What that leaves me with on the right side is 18 by itself, and I don't have to write the positive sign because it's implied. And then on the left side, I have a 5x plus a 3x. So my x stays the same. I'm just adding the coefficients. So 8x, right? 5 plus 3. And then I haven't done anything with this plus 2 yet. So now my equation looks a little bit simpler. It's 8x plus 2 equals 18. I want to move that 2 to the other side of the equation. So opposite of adding 2 is subtracting 2. So I'm going to do that. That leaves me with 8x on the left, 18 minus 2 on the right, which is 16. And then I'm going to divide both sides by 8. Okay, so right now, I went through that kind of fast. Right now my x is being multiplied by 8. Opposite of multiplication is division. So I'll divide both sides by 8. On the right, I have 16 divided by 8, which is going to be positive 2. Okay. As always, we're going to go back. We're going to double check that math. So I'm going to check our answer. So I'm going to rewrite my equation. 5x plus 2 equals -3x plus 18. And then I'm going to rewrite it, but instead of x's, I'm going to write positive 2. So 5 times 2 plus 2 equals -3 times 2 plus 18. So remember your rules of BEDMAS. You have to do your multiplication first. So 5 times 2 is 10. It was it plus? Oh, wow, I can't read my own writing. 10 plus 2. And then on the right side of the equation here, is this supposed to be an equal sign? I have -3 times 2, so a negative times a positive, that's going to be a -6 plus 18. Okay, 10 plus 2 is pretty easy, that's just going to be 12. -6 plus 18, again, using either a number line or a calculator, something to make sure if you're not sure about integers, but -6 plus 18 actually also is going to give you positive 12. So this equation is balanced. We solved for the variable correctly. Just firing through these, let's look at the next example. So the next example, we have 7 minus a equals 4a plus 2. Looking at our variables, we have a negative a on the left and a 4a on the right. When you have a negative term and a positive term, you want to move the negative term. So I'm going to add a to both sides of my equation. Remember that a variable by itself has a coefficient of 1. So when we're adding a, we're actually adding 1a. So 4a plus 1a, a stays the same. You're really just adding the coefficient. So 4 plus 1 is 5a. Okay, and then this plus 2 we haven't dealt with yet. So my equation looks a lot simpler now. Now this just becomes one of those two-step equations that we practiced solving a little bit yesterday and then a little bit 2 weeks ago. So right now I'm adding 2. If I want to get rid of that, the opposite of addition is subtraction. So I'll subtract 2 from both sides. 7 minus 2 is 5, and on the right I have 5a by itself. Right now my a is being multiplied by 5. The opposite of multiplication is division. So to get rid of that 5, I'm going to divide both sides by 5. That leaves me with a by itself on the right, and then 5 divided by 5 on the left is just going to be 1. So again, in this equation, our variable should be representing the number positive 1, but we're going to go through and check it just to make sure. Okay, so checking our answer, just rewriting our equation and then rewriting it with our number in place of the variable. So 7 minus a equals 4a plus 2. 7 minus 1 equals 4 times 1 plus 2. 7 minus 1, that's pretty straightforward. It's just going to be 6. 4 times 1 is going to be 4 plus 2. And then 4 plus 2 is also 6. So both sides of the equation are balanced. We solve for the variable correctly. Okay, there's one more problem here before we get into some word problems, and I think we have enough time, so let's solve it anyway. 18 minus 4x equals 2x. So another case of having a negative term and a positive term. You always want to move the negative term because then our numbers stay positive. So right now I'm subtracting 4x. The opposite of that would be adding it. So I'm going to add 4x to both sides. That leaves me with 18 by itself on the left, 2x plus 4x on the right. So the x stays the same. I'm just going to add the coefficients. So 2 plus 4 is 6. So this becomes 6x. Now this question's a little bit shorter than some of the other ones we were doing because I don't have any numbers now that I need to add or subtract, because on the right side of the equation to begin with, there were no stray numbers, right? It was just that term 2x. So now I'm just going to jump right into my division because right now my x is being multiplied by 6. I want to get rid of that 6, so I'm going to do the opposite operation, which is dividing. And to keep my equation balanced, I'll do it to both sides. So 18 divided by 6 is going to be 3, and I end up with x by itself on the right. So in this equation, x should be equal to positive 3. As always, I'm going to double check that just to make sure. So rewriting my equation, 18 minus 4x equals 2x. And then rewriting it, but instead of writing x, I'm going to put in positive 3. So 2 times 3. Following your order of operations, you're going to do this multiplication first. So negative 4, right? This negative sign stays with it. Negative 4 times positive 3 is going to be a negative 12. So you're going to have 18 minus 12. And on the right, you have 2 times 3, which is just going to be 6. 18 minus 12 is 6, so you end up with the same number on both sides of the equation. So surprise, surprise, this equation is balanced. We solved for the variable correctly. Again, a reminder that if you ever go back when you're doing these problems and you try and check your answer and you get different numbers on either side of the equation, that means that you did something wrong, and you're going to want to go back and double check your math to make sure that or figure out where you may have made the mistake, right? Maybe it was an integer that you didn't notice. Maybe you, divided instead of subtracting, something silly like that. But your numbers should always be the same on either side of the equation. Okay, now let's talk about everybody's favorite word problems. So all of the word problems that we're going to talk about can be solved by making an equation that looks something like this one here. So 4x plus 2 equals 3x plus 4. So both sides will have some sort of term with a variable, and then both sides will also probably have a number by itself. There might be some negative terms, so just pay attention very carefully. Most word problems for these type of equations will be comparing two of something. So if you're comparing two options, one side of your equation represents the first option, the other side of the equation represents the second option. Remember, whatever you're trying to solve for will represent the variable. So just like in the simple equation problems we were doing, the thing that we didn't know was the variable. You can usually identify the coefficient of the variables as an amount per variable. Any other numbers in the question will probably represent their own term. Look at the context of the numbers to decide whether the numbers are positive or negative. So let's look at this first example. So this one's about ticketing options. Now there is a question like this, and I can't remember if it was on your quiz or your assignment. I have both of them in my head right now. I can't remember which one it's on. Maybe it's both. Either way, this will be a good question for you guys to pay attention to. So there's two options for purchasing tickets. Option A costs $25 plus $7 per ticket. Option B costs $50 plus $2 per ticket. How many tickets would you have to buy for both options to cost the same? We said when we were introducing these word problems that if you were comparing two things, one side of the equation would represent the first option and the second side of the equation would represent the second option. So in this case, option A will be one side of the equation. Option B will be the other side. Okay, so let's look at option A. So option A costs $25 plus $7 per ticket. So $25 is going to be sort of a flat rate, right? They have to pay $25 no matter what. That doesn't change depending on number of tickets or anything like that. So option A is going to involve adding 25. Okay. The second part of option A is it's $7 per ticket. Now the thing that we don't know in this equation is how many tickets. So that's going to be our variable. Remember, your variable can be any letter that you choose. Knowing me, I'm going to choose X. So if it's $7 per ticket and I don't know how many tickets there are, it's going to be 7 times X, or unknown amount of tickets. Okay, so that's going to be option A. So $25 plus $7 times some unknown number of tickets. Option B is going to have a really similar format. It also has a flat rate of $50, so we're going to be adding 50 somewhere. And then it also has a rate per ticket, and it's $2 per ticket. So $2 per X number of tickets sold. Okay, the variable is the same on both sides of the equation because both questions involve number of tickets. How many tickets would you have to buy for both options to cost the same? This is where you're just going to solve for the variable X, right? Because X represents the number of tickets. If you solve for X, you answer this question. Okay, so I'm going to switch colors to sort of keep the two different parts of the question separate. So the first part of the question is making the formula or the equation. The second part is solving it. So 25 plus 7x equals 50 plus 2x. So we have two positive terms here, a positive 7x and a positive 2x. When you have two positive terms, you move the smaller one. So I'm going to move this 2x. Right now I'm adding it. The opposite of that is subtracting. So I'm going to subtract 2x from both sides of my equation. 25 isn't affected. 7x, I'm subtracting 2x from it, so that becomes 5x, right? 7 minus 2 is 5. And then on the right side, I just have 50. Okay, because I got rid of that 2x. Now what I want to do is I want to get these numbers on the same side of the equation. So I have 25 over here. It's a positive number, so to get rid of it, I'm going to do the opposite, which is subtract. So I'm going to subtract 25 from both sides of the equation. That leaves me with 5x by itself on the left. 50 minus 25 on the right is 25. And then to get x by itself, my last step, well, right now x is being multiplied by 5. The opposite of multiplication is division, so I'm going to divide both sides of my equation by 5. So x is going to be equal to 5. Okay, so remember what x represents. X means you would have to buy 5 tickets for both options to cost the same. Okay. Now, normally this is where we would go and check our answer, but I want to make sure we have enough time to do the last two word problems. So you guys know how to do that. You can feel free to go back and do that. If you go and check the answer and realize that it's wrong, let me know and we'll figure out what happened there. But I've done this question before and I'm pretty sure that it is correct. Okay, let's look at the next problem. Next problem says Ryan weighs 140 pounds and he gains 8 pounds per year. Frank weighs 160 pounds and he gains 3 pounds per year. How many years will it take for Ryan and Frank to be the same weight? Okay, so our variable is always going to represent the thing that we don't know. So the thing that we don't know is how many years it's going to take for Ryan and Frank to weigh the same. So X is going to be number of years. Okay, we're comparing two things. So one side of our equation is going to represent Ryan's situation, and then the other side is going to represent Frank's. So let's look at Ryan. Well, Ryan already weighs 140 pounds. Okay, that's a constant number. He weighs 140. So just like in the ticketing problem, it's like the flat rate, right? 140 pounds, that's sort of his base weight. So 140 pounds is going to be added here. The second thing we know about Ryan is that he's gaining 8 pounds per year. Now, X is the number of years, and he's gaining 8 per X number of years, right? So every year he's gaining 8 pounds. So we're going to make that represented by 8X. Okay, so that's Ryan's situation. Frank's situation is similar. He weighs 160 pounds, so a little bit more, and he only gains 3 pounds per year. Okay, so he would be 160 pounds plus 3 pounds per X number of years. Okay, that's the first part of this problem, is making that equation. Once you've done that, it's just a matter of solving it. So we have two positive terms again. We're going to solve for this exactly like the last problem. When you have two positive terms, you move the smaller one. So instead of adding 3x, we're going to do the opposite operation to get rid of it. So we end up with 140 plus 8x minus 3x is 5x. 160 by itself on the right. And then we're going to move this 140 to the other side. So 140, it's a positive number, so to get rid of it, we subtract it. That leaves us with 5x on the left and 160 minus 140 on the right, which is 20. And then last thing we need to do, right now our x is being multiplied by 5. Opposite of multiplication is division, so divide both sides by 5, and you end up with an answer of x equals 4. So X represents number of years. So at this rate, with Ryan gaining 8 pounds per year, Frank gaining 3, it's going to take them 4 years until they weigh the same amount. Okay. Again, you guys can go back and check the answer if you want to make sure that we did it correctly. Normally on an assignment, I definitely would say to do that. If you're on a quiz and you're running out of time, don't worry about it, because it's not for marks. It's just for your peace of mind to reassure you that you did the problem correctly. When you're doing the assignments, you have more time to check your answers. Definitely do it then. Okay, let's look at this last problem. So this last problem, this question is absolutely on. And again, I have both your assignment and your quiz in my mind, top of my mind, because I just looked at both of them. So this question is definitely on one of them, and I can't remember which one. I think it's your assignment. Maybe it's both, honestly. Again, another good question to pay attention to. I think the numbers are different, but it's the same names, same situation. And I know that because it's kind of a gross question. So this one says, Beatrice and Steve, they both have runny noses. Beatrice has a box with 60 tissues. She's blowing her nose 4 times per minute. Steve has a box with 44 tissues, and he's blowing his nose 2 times a minute. How many minutes will it take for Beatrice and Steve to have the same number of tissues? Okay, so a nice little gross question about blowing noses. So remember that when we're comparing two situations, one side of our equation is going to represent one side, and then the other will represent the other situation. So Beatrice's situation will be one side of the equation, Steve's is going to be the other. Our variable is always the thing that we don't know. So in this case, our variable is going to be number of minutes, and specifically number of minutes it takes for them to have the same number of tissues. So let's create Beatrice's side of the equation. She has a box with 60 tissues. Okay, so 60 tissues, that's a base rate, right? She's starting with 60 tissues. That's not going to change. So she has 60 tissues. That's a positive number. She's blowing her nose 4 times per minute. So the assumption that we're making is she's using one tissue every time she blows her nose. So when she's using that tissue, she no longer has it, right? She's using it. It's being taken away from the 60 that she started with. So in this case, we're actually going to be subtracting. Okay. Now she's blowing her nose 4 times per minute. So that means 4 tissues per minute. So 4 tissues per X number of minutes. Okay, so that's Beatrice's situation. Steve's is going to follow a very similar format, but he's starting with 44 tissues, so different number. And he's only blowing his nose 2 times a minute. Okay, so he's going to lose 2 tissues per X number of minutes. Okay, so this is where you want to pay attention to the question, because sometimes you're going to have positive values, sometimes negative. So it all depends on the context of the question. That's the first part taken care of. And honestly, that's the hardest part, is making the equation. Once you've done that, you guys are really good at solving them. So solving this equation, we have 2 negative variables this time. Okay, when you have 2 negative terms, you want to move the one with the bigger coefficient, because that's going to give us a positive term on the other side. So right now I have minus 4x. Opposite of that would be plus 4x. Do that to both sides of the equation. That leaves you with 60 on the left by itself and 44. Now it's minus 2x plus 4. So you have a minus 2 plus 4. It's actually going to give you a positive 2. Okay, so now this turns into 44 plus 2x, right? Because negative 2x plus 4x, that's going to be positive 2x. Okay, so again, paying attention to your integers, because they can definitely mess you up. The second thing we need to do, we need to move these numbers so that they're on the same side. So we're going to subtract 44 from both sides of the equation, because it's a positive number we're subtracting. So 60 minus 44, that's going to be 16 on the left, 2x on the right. Last thing that's happening is our x is being multiplied by 2. To get rid of that, we'll do the opposite operation, which is division. So I'm going to divide both sides of my equation here by 2. 2x by 2 just gives you 2, and then 16 divided by 2 is going to be 8. So remember what x represents. It represents the number of minutes it will take for them to have the same number of tissues. So after 8 minutes of blowing their nose using the tissue rate that is mentioned in the question, it'll take 8 minutes for them to have the same number of tissues. Okay, so we're going to leave it at that. There's like 3 minutes left of class. So what I will say is work on your assignments. So try that mathletics assignment and also work on assignment number 3. Like I said, some of the word problems on that assignment are very similar, if not the same, to the ones we just did. So it's a good idea to do work on them while they're still fresh in your mind. Quiz is still planned for next Wednesday, which I know I already said. We're going to continue with the rest of our topics the next few days. So we still have equations with brackets to go over, which actually probably will only take 1 lesson. And then we have a whole lesson dedicated to word problems. Some of them are similar to the ones we did today, but just sort of a little part of review that we'll do on Thursday. Okay, so we're going to work on that for the rest of this week. Do review all next week until the quiz on Wednesday. If anyone has any questions, please let me know. You can email me or message me on Teams. Otherwise, I will talk to you guys tomorrow.